You are touching something right now. Perhaps your phone, your bed, or the fabric beneath your fingers. Feels solid, certain, real. But what if that feeling is an illusion so complete that your mind has never questioned it? Because at the deepest level, what you are touching is not solid at all. It is almost entirely empty space, structured by something invisible, something stranger than anything we experience in daily life. And this is where our journey begins. Tonight, we gently drift into the quiet world of particle physics, a place where reality dissolves into patterns, probabilities, and hidden layers. A world so small that even light cannot reveal it directly. And yet, it defines everything you are. On Velorin's Sleepy Space Mysteries, we often explore the vastness of the cosmos, like in our journey through the largest structures in the universe. But tonight, we travel in the opposite direction, not outward, but inward toward the smallest known pieces of existence. And what we find there may feel even more mysterious than galaxies. Because as we move deeper, atoms will disappear, particles will blur, and the idea of things themselves will begin to fade. So a quiet question begins to form. If everything solid is mostly empty, if particles are not truly solid, then what is reality actually made of? If this kind of slow, cosmic exploration helps you relax, consider subscribing, liking the video, and turning on the bell so you don't miss future journeys. You can also join as a member if you'd like to support the channel. And before we continue, tell me softly in the comments, where in the world are you listening from tonight? Now, let's go deeper. As we begin to move deeper, the first layer of reality to quietly dissolve is the atom, something that for centuries was believed to be the final, indivisible building block of everything. The word itself comes from an ancient idea meaning uncuttable, a smallest possible piece beyond which nothing could exist. And for a long time, that idea felt satisfying. It gave the universe a sense of completeness, as if we had reached the bottom of the structure. But as science often reveals, what feels like an ending is usually just the beginning of a deeper question. When scientists first began to probe atoms more carefully, they noticed something unsettling. Atoms were not solid spheres at all. Instead, they were mostly empty space, with a tiny, dense center surrounded by a diffuse cloud of electrons. If you could somehow shrink yourself down and enter an atom, you would not find a compact object, but rather a vast emptiness, with only faint, flickering presences marking where particles might be. This alone already begins to reshape our intuition. The solidity you feel right now does not come from tightly packed matter. It comes from interactions, from invisible forces preventing particles from passing through one another. What feels firm is actually a delicate balance of repulsion, a kind of invisible pressure between fields. At the center of the atom lies the nucleus, incredibly small compared to the whole atom, yet containing almost all of its mass. And for a time, it seemed like we had finally found something truly solid. The nucleus was composed of protons and neutrons, tightly bound together, dense and stable. It felt like a deeper foundation, something closer to the truth. But even this layer could not hold. As experiments became more precise, scientists began to notice patterns that did not quite make sense if protons and neutrons were truly fundamental. When particles were fired at them at high energies, the results suggested that something inside was being struck. Something smaller, something more elementary. It was as if the nucleus itself had hidden structure, waiting to be uncovered. And so the journey continued inward. Protons and neutrons, once thought to be the core of matter, were revealed to be composed of even smaller entities known as quarks. These quarks are unlike anything we encounter in everyday life. They cannot be isolated, cannot be observed directly in the way we observe larger objects. Instead, they exist in a kind of permanent partnership, bound together so tightly that attempting to separate them simply creates new particles. This introduces one of the first truly strange ideas in particle physics, that some things cannot exist alone. No matter how much energy you use, no matter how hard you try, a single quark will never appear in isolation. It is not just difficult. It is fundamentally forbidden by the rules of the universe. And this raises a quiet, lingering question that we will carry forward. If the building blocks of matter cannot exist independently, then what does it mean to call them building blocks at all? As scientists uncovered quarks, they expected perhaps a small, manageable set. But instead, they found a growing collection of particles with different properties, different masses, different behaviors. It began to feel as though the deeper we looked, the more complicated reality became. Instead of simplicity, there was a kind of explosion of possibilities. This period became known as the particle zoo, a time when the number of discovered particles grew rapidly, almost chaotically. New particles appeared in experiments, each one needing a name, a classification, an explanation. It was as if nature was revealing a hidden library of forms, far richer than anyone had anticipated. And yet, within that apparent chaos, there were hints of order. Patterns began to emerge, subtle symmetries linking different particles together. Families formed, relationships appeared, and slowly, a new picture began to take shape. The many particles of the zoo were not all fundamental. They were combinations, arrangements, different expressions of a smaller set of underlying components. This realization is deeply important because it echoes something we see at larger scales. Just as countless molecules are built from a limited set of atoms, the bewildering variety of particles may arise from simpler ingredients arranged in different ways. And so the question evolves again. If atoms were not fundamental, and nuclei were not fundamental, and even protons and neutrons were not fundamental, then how deep does this structure go? Is there a final layer waiting somewhere below quarks? Or is reality an endless descent, each level revealing another beneath it? As we continue, we will begin to see that this question is not just scientific. It becomes philosophical, even personal, because whatever answer we find, it applies not only to distant particles but to you. The matter that forms your body is part of this same layered structure. The same hidden components, the same interactions, the same quiet rules. And as we move further, we will begin to explore not just what these particles are, but what holds them together. Because structure alone is not enough. Something must bind it. Something must connect it. Something must make it real. As the strange idea of quarks settled into the foundations of physics, something even more unsettling began to emerge. Not just that matter had deeper layers, but that these layers did not behave like things in the way we naturally understand them. Up to this point, we could still imagine particles as tiny objects, like grains of sand or miniature spheres. But as experiments became more refined, that picture began to quietly fall apart. When scientists studied how quarks behaved inside protons and neutrons, they found something unexpected. The quarks were not sitting neatly in fixed positions. They were in constant motion, exchanging energy through invisible carriers, appearing and disappearing in a restless, almost fluid-like dance. The interior of a proton was not a static structure. It was a dynamic, shifting system where certainty gave way to probability. And this is where our intuition begins to lose its footing. Because in this deeper layer of reality, particles are not solid objects with clear boundaries. Instead, they are better described as excitations, small disturbances in underlying fields that fill all of space. Imagine a calm ocean. A wave appears, rises, and then fades. The wave is not separate from the ocean. It is the ocean temporarily shaped into a pattern. In much the same way, what we call a particle may simply be a localized ripple in a field that exists everywhere. This idea changes everything, because if particles are not independent objects but patterns in fields, then the concept of stuff becomes less meaningful. What we think of as matter is not made of little solid pieces stacked together. It is made of activity, of vibrations, of something continuously happening rather than something simply existing. And yet, even as this picture becomes more abstract, it somehow explains the world more accurately than anything before it. Returning briefly to the particle zoo, the chaotic collection of particles discovered in earlier experiments, we now begin to see it differently. What once looked like an overwhelming list of unrelated entities becomes a set of possible patterns that fields can form. Different combinations of quarks, different energy states, different arrangements, all of them are expressions of the same underlying principles. The zoo was not chaos after all. It was diversity emerging from simplicity. But even with quarks and their combinations, something was still missing. There were particles that did not fit into this framework of strong interactions. Particles that did not participate in the force that binds quarks together. These were the leptons, a quieter, more subtle family of particles that would reveal another essential half of reality. The most familiar of these is the electron. It is what surrounds the nucleus in an atom, what defines chemistry, what allows matter to form stable structures. Without electrons, atoms would not exist in the way we know them. And yet, unlike quarks, electrons do not seem to have internal structure. They behave as if they are truly fundamental, at least as far as we can currently tell. But the electron is not alone. There are heavier cousins, like the muon and the tau, which behave almost identically to the electron but carry more mass and exist only briefly before decaying. And alongside each of these is an even more elusive partner, the neutrino. Neutrinos are among the strangest entities in the universe. They barely interact with anything at all. Trillions of them are passing through your body right now, streaming from the sun and distant cosmic events, and yet you feel nothing. This introduces another quiet mystery. Why does nature repeat itself in these families? Why have multiple versions of essentially the same particle, differing only in mass? The electron, the muon, the tau, they seem redundant, almost unnecessary. And yet they exist, and their existence hints at deeper rules we do not yet understand. So now the picture of matter becomes richer, but also more mysterious. On one side, we have quarks, which combine to form the complex structures of protons, neutrons, and many other particles. On the other side, we have leptons, which exist more simply, shaping atoms and carrying energy across the universe. Together, they form the basic ingredients of matter as described by modern physics. But even this is not the full story, because knowing what matter is made of does not explain how it holds together or why it behaves the way it does. Quarks do not simply sit next to each other by coincidence. Electrons do not orbit nuclei randomly. There are forces at work, invisible interactions that bind, repel, transform, and shape everything we see. And these forces are not just background effects. They are just as fundamental as the particles themselves. So another question begins to form gently, almost unnoticed. If particles are patterns in fields, and matter is built from these patterns, then what governs their behavior? What determines how they interact, how they combine, how they create the stable world we experience? In other words, what holds reality together? As we move forward, we will begin to explore these forces, not as abstract ideas, but as something surprisingly tangible. Something that can be described in terms of exchanges, interactions, and connections between the smallest elements of existence. And in doing so, we may discover that what we call touch, structure, and even existence itself is not what it seems. By the time physicists began to understand quarks and leptons as the two fundamental families of matter, a quiet realization started to settle in. Knowing what things are made of is only half the story. Because matter alone, no matter how carefully described, cannot explain why anything holds together, why atoms remain stable, or why the universe does not simply dissolve into a cloud of disconnected fragments. Something else must be present. Something that binds, shapes, and governs all these particles. And this is where the idea of forces begins to take on a new meaning. In everyday life, forces feel intuitive. You push something and it moves. You drop something and it falls. A magnet pulls, a surface resists. These experiences make forces feel like direct interactions between objects. But at the level of particle physics, this familiar picture becomes something far more subtle and far more beautiful. Instead of thinking of forces as pushes or pulls, physicists describe them as exchanges. Not exchanges of objects we can see, but exchanges of tiny, invisible carriers that pass between particles, linking them together. Imagine two people standing in the dark, tossing a ball back and forth. Even if you cannot see the ball, you would notice the rhythm, the connection, the invisible coordination between them. In a similar way, particles interact by continuously exchanging these carriers, creating what we perceive as forces. This idea transforms our understanding completely, because now forces are not something separate from matter. They are interactions, ongoing conversations between particles, mediated by these exchange carriers. And each fundamental force has its own type of messenger. The most familiar of these is the electromagnetic force, carried by particles known as photons. Photons are often associated with light, but their role is much broader. Whenever charged particles interact, they are effectively exchanging photons, even if no visible light is produced. The feeling of touching something, the resistance you experience when pressing your hand against a surface, is ultimately the result of electromagnetic interactions preventing the electrons in your atoms from overlapping with those in the object. So when you feel solidity, what you are really feeling is a kind of invisible negotiation between particles, mediated by countless tiny exchanges. And this leads to a quietly astonishing thought. Nothing ever truly touches. At the deepest level, your hand never actually makes contact with anything. Instead, it is held at a distance by electromagnetic forces, creating the illusion of contact. But electromagnetism is only one part of the story. Inside the nucleus, where positively charged protons should repel each other strongly, there exists an even more powerful force, one that holds them together despite this repulsion. This is the strong force, and it operates at a scale so small and with such intensity that it binds quarks into protons and neutrons, and those nucleons into atomic nuclei. The carriers of this force are called gluons, and their behavior is unlike anything in our everyday experience. While most forces weaken with distance, the strong force does the opposite. The further quarks are pulled apart, the stronger the force becomes, as if the universe itself resists their separation. This is why quarks can never be isolated. If you try to pull them apart, the energy you put in does not separate them. Instead, it creates new quark pairs, maintaining the balance. It is as though the fabric of reality refuses to allow certain things to exist independently. And this reinforces a pattern we have seen before, that at the deepest level, isolation may not be possible. Everything exists in relation, in connection, in interaction. There is also the weak force, quieter but no less important. It is responsible for transformations, for the way particles can change from one type into another. It governs processes like radioactive decay and plays a crucial role in the reactions that power the sun. Without the weak force, the universe would be static, unable to evolve in the ways that lead to stars, planets, and life. So now we begin to see a more complete picture. Matter is not just built from particles, it is shaped by interactions. Quarks and leptons provide the structure, but forces provide the dynamics. And these forces are not external influences. They are woven into the very definition of what particles are and how they exist. At this point, another quiet question begins to emerge. If everything we experience, solidity, motion, transformation, is the result of these invisible exchanges, then what is actually real? Is it the particles themselves, or the interactions between them? Because without interactions, particles would have no meaning. They would not combine, would not form structures, would not create anything recognizable. Perhaps reality is not made of things, but of relationships. And as we continue, we will explore an even deeper layer of this idea, something that challenges one of our most basic intuitions. Because so far we have spoken about particles and forces as if they exist within space. But what if there is something even more fundamental, something that fills all of space itself, and quietly gives particles one of their most familiar properties: mass? Why do particles have weight? Why do they resist motion? The answer to that question will take us into one of the most subtle and profound discoveries in modern physics. A discovery that suggests that even the property of having mass is not intrinsic, but arises from interaction with something unseen. And once again, reality will become just a little more mysterious. As we move deeper into this quiet structure of reality, the idea of mass begins to feel less obvious than it once did. In everyday life, mass seems simple. It is the weight of an object, the resistance you feel when trying to push something, the sense that some things are heavy and others are light. It feels like a built-in property, something that belongs naturally to matter. But at the level of particle physics, this intuition begins to dissolve. Because when scientists tried to describe the fundamental particles using the most elegant and consistent mathematical frameworks, something strange appeared. The equations worked beautifully, but only if many particles had no mass at all. In that version of reality, particles would move at the speed of light, never slowing down, never forming stable structures. Atoms would not exist. Neither would stars, planets, or anything familiar. So the question became unavoidable. Where does mass actually come from? It could not simply be inserted into the equations without breaking their symmetry. And symmetry in physics is not just aesthetic. It is what ensures that the laws of nature remain consistent and predictable. Breaking that symmetry arbitrarily would cause the entire framework to collapse. So physicists searched for a deeper explanation, something that could preserve the elegance of the theory while still allowing particles to have mass. What they discovered was not a particle at first, but a field that exists everywhere, invisible, constant, and impossible to turn off. This is known as the Higgs field. Unlike particles, which can appear and disappear, fields are more like the background of reality itself. They fill all of space, even in what we would call a vacuum. And the Higgs field has a very special property. When particles move through it, they interact with it. And this interaction gives rise to what we perceive as mass. To imagine this, think of moving through a medium. If you walk through empty air, you move easily. But if you try to walk through water, or through something thicker, your motion is slowed. You feel resistance, not because you have changed, but because of your interaction with the environment around you. In a similar way, particles moving through the Higgs field experience a kind of resistance, not in the sense of friction, but in the sense that their motion is altered. This alteration manifests as mass. So mass is not something particles simply possess. It is something that emerges from interaction. And this is a subtle but profound shift, because it means that one of the most basic properties of matter, weight itself, is not intrinsic. It depends on something else. something unseen, always present, quietly shaping the behavior of everything. Different particles interact with the Higgs field in different ways. Some interact strongly and therefore appear heavy. Others interact only weakly and appear light. And some, like the photon, do not interact with the Higgs field at all, which is why they have no mass and move at the speed of light. This creates a spectrum of masses across the particles of the universe, not because they are fundamentally different in substance, but because they relate differently to this underlying field. And this brings us to another quiet realization. Once again, what we thought was a property of things turns out to be a relationship. Mass is not just there. It is the result of interaction. Just like forces, just like structure, just like everything we have seen so far. Reality continues to shift away from being made of independent objects and toward being a network of relationships, interactions, and patterns. The Higgs field itself remained purely theoretical for decades. It was a necessary part of the equations, but there was no direct evidence that it existed. And so, one of the greatest challenges in modern physics became clear. If the field is real, then there must be a corresponding particle, a kind of ripple in that field, just as photons are ripples in the electromagnetic field. This particle would be incredibly difficult to detect. It would require enormous energies to produce, and it would vanish almost instantly after appearing. And yet, after decades of effort, involving thousands of scientists and some of the most complex machines ever built, that particle was finally observed. The Higgs boson. Its discovery confirmed that the field was not just a mathematical idea, but a real feature of our universe. And with that, one of the deepest mysteries of physics found an answer, at least partially. We now understand how particles acquire mass. But even here, the answer opens new questions. Why does the Higgs field exist at all? Why does it have the particular strength that it does? Why do particles interact with it in such specific ways? These questions remain unanswered. And so, even as we uncover deeper layers of understanding, the horizon continues to move. The map becomes clearer, but never complete. As we reach the end of this part of the journey, we can begin to gather what we have seen. Matter is not solid. Particles are not objects. Forces are exchanges. Mass is interaction. Each layer we uncover replaces something familiar with something more subtle, more interconnected, more abstract. And yet, somehow, all of this gives rise to the world we experience. A world that feels stable, continuous, and real. So a final question lingers here, gently, as we prepare to move forward. If everything we experience emerges from invisible fields and interactions, then is reality something that exists, or something that is constantly happening? If you are still listening, let me know softly by commenting 1. So I know you are still here with me, drifting through these quiet layers of existence. As we reach the final stretch of this part of the journey, something subtle begins to settle into place. Not as a clear answer, but as a shift in perspective. We started with the idea that matter is built from atoms, then discovered atoms are mostly empty, then that their cores are made of smaller parts, and then that even those parts are not truly solid. Along the way, particles became patterns, forces became exchanges, and mass itself became a relationship with an invisible field. And now, standing quietly at this point, we can begin to sense the outline of a deeper understanding. Because when you step back and look at all of this together, a pattern emerges. Nothing exists in isolation. Quarks cannot exist alone. They are permanently bound, defined by their relationships. Electrons only make sense in the context of atoms and interactions. Forces are not separate entities, but ongoing exchanges between particles. Even mass depends on interaction with a field that fills all of space. Everywhere we look, the same idea repeats itself in different forms. Existence is not about independent things, but about connections. And this realization begins to gently reshape the way we think about reality itself. In everyday life, we tend to imagine the world as made of objects. Solid things that exist on their own, interacting occasionally. But particle physics suggests something different. It suggests that what we call things are actually stable patterns within a much deeper web of activity. They persist not because they are fundamentally solid, but because the interactions that define them are stable enough to last. A proton, for example, is not a fixed object in the way a stone appears to be. It is a constantly shifting arrangement of quarks and gluons, exchanging energy, fluctuating in subtle ways. And yet, it remains identifiable, stable enough to form atoms, to build matter, to create the world we experience. So stability is not stillness. It is balance within motion. And this idea extends far beyond particles. Atoms are stable patterns of electrons interacting with nuclei. Molecules are stable arrangements of atoms. Biological structures are stable systems of molecules. And at every level, what appears solid and permanent is actually dynamic, sustained by ongoing interactions. This brings us back to one of the earliest questions we asked. If everything is mostly empty space, if particles are not solid, if everything is constantly in motion, then why does the world feel so stable? The answer seems to lie in scale. At the level we experience, these interactions average out. The fluctuations become too small to notice, the probabilities become effectively certain, and the constant motion gives rise to stable patterns. What feels like solidity is actually consistency over time. What feels like permanence is actually persistence of structure. In a way, reality is less like a collection of objects, and more like a process that maintains itself. And this leads to a quiet, almost philosophical reflection. You too are part of this process. The atoms in your body are not fixed. They are constantly exchanging particles, interacting with the environment, participating in the same fundamental processes we have been exploring. The particles that make you up are not static pieces assembled once and for all. They are part of an ongoing flow, a continuity of interactions that gives rise to the sense of a stable self. So when we ask what something is made of, the answer is never just a list of components. It is also a description of how those components relate, interact, and sustain each other. And this is where the journey begins to turn outward again. Because everything we have explored so far, quarks, leptons, forces, fields, all of it comes together in a single framework known as the Standard Model of Particle Physics. This framework does not just list particles. It describes the rules that govern how they behave, how they interact, and how they give rise to the structure of the universe. It is, in a sense, a map of the invisible, and it is one of the most successful scientific theories ever created. It can predict experimental results with astonishing accuracy. It explains phenomena across a vast range of scales, from the smallest particle interactions to processes occurring inside stars. It has been tested again and again, and each time it has held up with remarkable precision. And yet, it is not complete. Even at this level of understanding, there are gaps, questions that remain unanswered, phenomena that do not fit neatly into the framework. And these gaps hint that there may be even deeper layers still waiting to be discovered. So as we gently close this part of the journey, we find ourselves in a familiar place, not at an ending, but at the edge of another beginning. We have seen how matter is built, how it behaves, how it holds together. But now we must ask, how complete is our understanding? What does the Standard Model explain? And what does it leave out? And perhaps most intriguingly, what lies beyond it? In the next part, we will step back and look at the full picture, the grand structure that brings all of these pieces together, and the quiet mysteries that still remain, waiting in the darkness beyond our current map. As we begin this next part of the journey, it helps to pause for a moment and look at everything we've gathered so far. Not as separate ideas, but as pieces of a single, quiet structure. We have seen that matter is built from quarks and leptons, that these particles are not solid objects but patterns in fields, that forces are exchanges of invisible carriers, and that even mass arises from interaction with something unseen. And yet, all of these ideas, as abstract as they may feel, come together into a single framework that physicists use to describe reality at its deepest known level. This framework is known as the Standard Model. At first, the name sounds almost modest, as if it were just one model among many. But in truth, it is one of the most precise and successful descriptions of nature ever created. It is not simply a list of particles. It is a set of rules, a language, a kind of grammar that describes how the universe behaves at its most fundamental scale. And what makes it remarkable is not just what it includes, but how well it works. The Standard Model brings together everything we have explored so far. It organizes quarks into families, showing how they combine to form protons, neutrons, and other particles. It describes leptons, from the familiar electron to the nearly invisible neutrino. It includes the carriers of force photons, gluons, and the heavy particles responsible for weak interactions. And it incorporates the Higgs field, explaining how particles acquire mass. Each piece fits into a larger pattern, guided by deep symmetry's rules that ensure consistency across all interactions. These symmetries are not something we can see directly. They are mathematical, almost abstract, but they dictate how particles must behave, how forces must operate, and how everything fits together into a coherent whole. And the astonishing part is this: When scientists use the Standard Model to predict the outcome of experiments, those predictions match reality with incredible accuracy. In some cases, the agreement is so precise that it extends to more than 10 decimal places. It is as if the universe is following this set of rules with unwavering consistency. But as calming as that may sound, there is something quietly unsettling beneath it, because even though the Standard Model works so well, it does not explain everything. It is like having a map that perfectly describes a vast landscape, and yet still leaves entire regions blank. For example, the Standard Model does not include gravity, the force that governs the motion of planets, stars, and galaxies, the force that shapes the large-scale structure of the universe, is not part of this framework. At the level of particles, gravity is so weak that it can often be ignored. But that does not mean it is unimportant. It simply means that our most successful theory of the small does not yet connect with our understanding of the large. And this separation is one of the deepest puzzles in physics. There are also other mysteries, quieter, but just as profound. The Standard Model describes neutrinos, those elusive particles that pass through matter almost unnoticed. But for a long time it assumed they had no mass. And yet, experiments have shown that neutrinos do have a tiny mass, so small that it is difficult to measure, but undeniably present. This means that the Standard Model, as originally formulated, is incomplete. It needs to be extended, adjusted, or perhaps rethought in some deeper way. There is also the question of why particles come in families. Why are there 3 generations of quarks and leptons? Why does the electron have heavier counterparts like the muon and tau? The Standard Model describes them, predicts their behavior, and incorporates them seamlessly, but it does not explain why they exist in the first place. It is as if we have discovered the rules of a game, but not the reason those rules were chosen. And then there is something even more mysterious. When astronomers observe galaxies and the large-scale structure of the universe, they find that the visible matter, the stars, the gas, the dust, accounts for only a small fraction of what is actually there. Most of the mass appears to be invisible, something we call dark matter. It does not interact with light, does not behave like ordinary particles, and yet its gravitational effects are undeniable. The Standard Model has no place for it, cannot explain what dark matter is made of. And beyond that, there is dark energy, an even stranger phenomenon that seems to be driving the accelerated expansion of the universe. Space itself appears to be stretching faster and faster over time, as if pushed by some unseen influence. And once again, the Standard Model remains silent. So now we find ourselves in a curious position. We have a theory that works with extraordinary precision, and yet leaves some of the biggest questions unanswered. It is both a triumph and a reminder of how much we still do not know. And perhaps this is where the journey becomes most interesting, because when a theory works so well, even the smallest discrepancy becomes important. A tiny deviation from prediction, a slight anomaly in an experiment, could be the first hint of something beyond the Standard Model. Something deeper, something that reshapes our understanding once again. So as we continue, we will begin to explore these edges, these places where the map begins to fade, where known physics meets the unknown, because it is often at the boundaries of understanding that the most profound discoveries are waiting. As we gently move further into the edges of the Standard Model, something interesting begins to happen. The questions themselves start to feel larger than the answers we currently have. Up until now, the model has given us clarity. It has told us what particles exist, how they interact, and how they combine to form the structure of reality. But when we look closely at what it cannot explain, the silence becomes just as meaningful as the knowledge. One of the most striking of these silences surrounds dark matter. When scientists observe galaxies, they notice something that does not quite make sense. Stars orbit the centers of galaxies at speeds that should cause them to fly apart, if only the visible matter were holding them together. And yet, the galaxies remain intact, as if there is an unseen mass providing additional gravity. This invisible presence does not emit light, does not absorb it, and does not interact in ways we can easily detect. But its influence is unmistakable. It shapes galaxies. It bends light through gravitational lensing. It forms the scaffolding upon which cosmic structures grow. And yet, within the Standard Model, there is nothing that fits this role. None of the known particles have the right properties. Neutrinos, for example, are too light and move too quickly to account for the observed effects. Quarks and electrons interact too strongly with light. The entire framework, as precise as it is, seems to be missing something essential. So a quiet possibility begins to emerge. Perhaps there are particles we have not yet discovered. Particles that exist beyond the Standard Model, interacting weakly, or perhaps in entirely new ways, shaping the universe without revealing themselves directly. If this is true, then the matter we are familiar with, everything we see, touch, and experience, may be only a small fraction of what actually exists. And this leads to a deeply humbling thought. Most of the universe may be made of something we do not yet understand. But the mystery does not end there. There is also dark energy, a phenomenon even more subtle, yet even more dominant. Observations of distant galaxies show that the universe is not just expanding, but accelerating in its expansion. Space itself is stretching faster over time, as if driven by a hidden force embedded in the fabric of reality. This is not something we can easily visualize. It is not matter pulling or pushing in the usual sense. It is something inherent to space itself, a kind of energy that seems to resist gravitational collapse and instead drives everything apart. And once again, the Standard Model offers no clear explanation. So now we are faced with two enormous unknowns: dark matter shaping structure, dark energy shaping expansion. Together, they make up the vast majority of the universe. And yet, they lie completely outside our most successful theory of fundamental physics. This creates a quiet tension, because on one hand, the Standard Model is incredibly precise. It describes the behavior of known particles with extraordinary accuracy. But on the other hand, it does not describe most of what exists. It is like having a detailed map of a small island, while knowing that a vast ocean surrounds it. And this is where physics begins to shift from certainty back into exploration. Scientists are not content with these gaps. Around the world, experiments are searching for signs of new particles, new forces, new interactions. Deep underground detectors are waiting for rare collisions with dark matter particles. Massive accelerators are probing higher energies, hoping to create something unexpected. Observatories are mapping the universe with increasing precision, looking for subtle clues hidden in the behavior of galaxies and cosmic radiation. Each experiment is like a quiet question, asked again and again in different ways. What are we missing? At the same time, theorists are exploring ideas that extend beyond the standard model. Some propose entirely new families of particles. Others suggest additional dimensions of space, hidden from our perception. Some imagine symmetries that are broken in ways we have not yet detected. These ideas may seem abstract, but they are grounded in the same approach that led to the standard model itself, searching for patterns, for consistency, for deeper explanations. And yet, despite all this effort, no clear answer has emerged, which brings us to another subtle realization. Not knowing is not failure. It is part of the process. In fact, it is often the most important part, because every major breakthrough in physics has come from a place where something did not fit, where observations and theory diverged just enough to suggest that something deeper was waiting to be discovered. So these mysteries, dark matter, dark energy, the limitations of the standard model, they are not just problems to be solved. They are invitations. Invitations to look beyond what we currently understand, to question assumptions, to imagine possibilities that extend beyond our current map. And as we continue, we will explore one more layer of this mystery, one that connects the smallest particles to the largest structures in the universe. Because in the end, the story of particle physics is not just about what things are made of, but about how everything, from the tiniest scale to the cosmic horizon, fits together into a single unfolding reality. As we continue drifting along the edge of what we understand, another quiet thread begins to connect everything we've explored, a realization that the smallest particles and the largest structures in the universe may not be separate stories at all, but parts of the same unfolding process. What happens inside a proton, and what shapes entire galaxies, may ultimately be governed by the same underlying rules, even if we do not yet fully see how they connect. This idea becomes especially important when we consider the early universe. Long before stars, planets, or even atoms existed, the universe was a vastly different place. It was hotter, denser, and filled with energy so intense that the distinctions between particles blurred. In those first moments after the beginning, what we now think of as separate forces, electromagnetism, the weak force, may have been unified into a single interaction. The particles we know today may not have existed in their familiar forms. Instead, reality was simpler, but also more extreme. As the universe expanded and cooled, something remarkable happened. The symmetries that once held everything together began to break. Not in a destructive sense, but in a creative one. From this breaking of symmetry, new properties emerged. Forces separated. particles acquired mass through interaction with the Higgs field. Structures began to form. It is as if the universe started in a perfectly balanced state, and then gently unfolded into the complex world we now observe. And this process still echoes today. Because when physicists use powerful accelerators to collide particles at extremely high energies, they are, in a sense, recreating tiny glimpses of those early conditions. For a brief moment, the energy densities become so high that new particles can form, symmetries can be restored, and hidden aspects of reality can reveal themselves. This is why particle physics is not just about the present. It is also about the past. Every collision is like a question asked of the universe. What were you like in the beginning? And the answers come not as images, but as patterns, traces, distributions of energy that must be carefully interpreted. Scientists do not see particles directly. They see the aftermath, the signatures left behind as particles decay, transform, and interact. This connects back to something we touched on earlier. Reality at this level is not observed directly. It is inferred, and yet, through careful measurement and extraordinary precision, these inferences become reliable, building a picture of the unseen that is as consistent as anything we experience directly. But even with this ability to probe the early universe in miniature, something remains unresolved. The Standard Model suggests that, at very high energies, certain forces become unified. And indeed, experiments have shown hints of this unification. But not completely. The strengths of the forces do not quite converge in the way we might expect if there were a single, deeper force underlying them all. This has led physicists to consider the possibility of grand unification, a theory in which the strong, weak, and electromagnetic forces are all different expressions of a single interaction at extremely high energies. If such a theory is correct, then the diversity of forces we observe today would be the result of symmetry breaking as the universe cooled, much like the way the Higgs field gives particles mass. And if we follow this idea even further, another question emerges. Could gravity also be part of this unification? Present, gravity stands apart. It is described by a different theory, one that works beautifully at large scales but does not fit easily into the quantum framework of particle physics. Bridging this gap, finding a way to describe gravity in the same language as particles and fields, is one of the greatest challenges in modern science. Some theories suggest that gravity may be carried by a particle called the graviton, though it has never been observed. Others propose entirely new ways of thinking about space and time, suggesting that what we perceive as gravity may emerge from deeper quantum processes. These ideas remain speculative, but they point towards something important. Our current understanding, as powerful as it is, may still be incomplete at a very fundamental level. And this brings us back to a familiar feeling, the sense that each answer opens the door to new questions. We have traced matter down to quarks and leptons. We have understood forces as exchanges of particles. We have seen mass emerge from interaction with a field. We have mapped these ideas into the Standard Model. And yet, the connections between these pieces, especially at the highest energies and the largest scales, remain partially hidden. It is as if we are looking at a puzzle where many pieces are in place, but the full image has not yet revealed itself. So the question becomes softer now, less about specific particles or forces, and more about the nature of understanding itself. Are we close to a final theory, or are we still only at the beginning? Is there a single, simple principle underlying everything? Or is reality layered in ways that continue indefinitely? As we move forward, we will explore one more dimension of this mystery, one that touches not only on physics, but on existence itself. Because when we ask what the universe is made of, we are also quietly asking what we are made of, and what it means to exist within this vast, unfolding structure. As we continue this quiet descent into deeper understanding, something begins to shift, not just in what we know about the universe, but in how we think about existence itself. Because when physics reaches its limits, when equations begin to stretch and theories no longer fully connect, the questions become less about specific particles and more about the nature of reality as a whole. One of the most subtle of these questions concerns the idea of completeness. Is the universe ultimately understandable through a single, unified theory? A set of rules so complete that nothing lies beyond it? Or is every theory we create simply an approximation, a map that works within a certain range, but never captures the full territory? The Standard Model, as we have seen, is extraordinarily successful. It describes the known particles and their interactions with remarkable precision. But it also leaves gaps, and not small gaps, but vast ones. Dark matter, dark energy, gravity, the origin of particle masses, the reason for 3 generations, all of these remain unanswered. And this suggests something important. Perhaps our current theories are not final truths, but layers of understanding. Each layer works within its domain. Each reveals something real, but none may be complete on its own. This idea is not new in physics. It has happened before. Newton's laws describe motion with great accuracy in everyday situations. But at very high speeds or in strong gravitational fields, they give way to relativity. Quantum mechanics describes the behavior of particles with extraordinary precision, but it does not easily merge with gravity. Each theory is powerful, but also limited. So it may be that the Standard Model is another layer, a very deep and accurate one, but still part of a larger structure we have yet to fully see. And this leads to a gentle but profound possibility. Reality may not be built on a single, simple foundation, but on a series of interconnected layers, each revealing new patterns as we move deeper. If this is true, then the question, what is the universe made of, may not have a final answer in the way we expect. Instead, it may be an ongoing exploration, a journey without a clear endpoint. And yet, even within this uncertainty, there is a kind of coherence, because every layer we have uncovered so far shares a common theme: interaction. Particles are defined by how they interact. Forces are interactions. Mass arises from interaction. Structure emerges from stable interactions. Again and again, the same idea returns. Reality is not made of isolated things, but of relationships, And this idea becomes even more intriguing when we consider space itself. In classical thinking, space is simply a stage, an empty background in which events occur. But modern physics suggests something more subtle. Space may not be empty at all. It may have structure, properties, even fluctuations at the smallest scales. Fields exist within it. Energy can arise from it. And at extremely small distances, the very concept of space may begin to lose its meaning. Some theories suggest that space and time themselves could emerge from deeper, more fundamental processes, perhaps from networks of relationships between quantum states, or from structures that do not resemble space as we perceive it. If that is true, then even the idea of where something exists becomes less clear. Particles would not simply be located in space. Space itself would be part of the same underlying system. And now the picture becomes even more abstract, but also strangely unified. Matter, forces, space, and perhaps even time, all arising from deeper patterns of interaction. At this point, it becomes difficult to separate physics from philosophy, because we are no longer just describing how things behave. We are asking what it means for something to exist at all. If particles are not objects but patterns, if space is not a container but part of the system, if everything is defined by interaction, then existence itself may be something dynamic, something that is continuously unfolding. Not a static collection of things, but an ongoing process. And within that process we find ourselves. This is perhaps the most quiet and profound connection. The same principles that govern the smallest particles also give rise to the structures that allow consciousness, perception, and experience. The atoms in your body follow the same rules as those in distant stars. The interactions that hold your cells together are the same interactions that shape galaxies. So when we explore particle physics, we are not just studying something distant or abstract. We are studying the foundation of our own existence. And this brings us back gently to one of the earliest questions we asked. What is reality made of? After everything we have seen, the answer no longer feels like a simple list of particles. Instead, it feels more like a pattern, a network, a process, a continuous unfolding of interactions that give rise to structure, stability, and experience. And yet, even now, something remains just beyond reach. Because for all our understanding, for all our theories, we still do not know if we have reached the deepest level. There may be something beyond quarks, beyond fields, beyond even the concepts we are currently using. And if there is, it may change everything once again. As we move into the final part of this journey, we will gently bring these ideas together, not to find a final answer, but to rest within the mystery itself. Because sometimes understanding does not come from resolving every question, but from learning how to sit quietly with the unknown. As we arrive at the final segment of this part, something soft and almost paradoxical begins to emerge. The more deeply we understand the structure of reality, the less it resembles something fixed, and the more it begins to feel like something unfolding. Not a collection of solid pieces arranged in space, but a continuous process, a quiet, intricate dance that never truly stops. We began with the idea of matter, something stable, something we could point to and say, this is what exists. But step by step, that certainty dissolved. Atoms gave way to emptiness. Nuclei gave way to quarks. Particles gave way to fields. And even those fields now seem less like objects and more like underlying conditions from which patterns arise. And through all of this, one idea has remained constant. Nothing exists on its own. Everything is defined by how it relates to everything else. This is not just a scientific observation. It is a shift in perspective, because it suggests that existence itself may not be about things, but about connections, about interactions, about relationships that persist long enough to create the illusion of stability. And that illusion, while not false, is only part of the story. Take something as simple as a particle. At first, it feels like a point, a tiny object with a definite position and identity. But as we have seen, that picture does not hold at deeper levels. Particle is not a little sphere sitting in space. It is a localized excitation, a pattern in a field, a region where something is happening. It has properties, yes, a mass, charge, spin, but these properties are not independent. They arise from interactions, from the way that pattern fits into the larger structure of the universe. So even the smallest unit of matter is not truly a thing. It is an event, a happening. And if that is true for particles, then perhaps it is true at every scale. A proton is a stable pattern of quarks and gluons. An atom is a stable pattern of electrons and nuclei. A molecule is a stable pattern of atoms. A living organism is a stable pattern of molecules. At each level, what we call an object is really a process that maintains its form over time. And this realization brings a kind of quiet coherence to everything we've explored. Because now the universe begins to look less like a structure and more like a flow, not chaotic, not random, but structured motion, patterns that emerge, persist, and eventually transform. Even the forces we described earlier, electromagnetism, the strong force, the weak force, are not static influences. They are ongoing exchanges, continuous interactions that sustain the structure of matter. And even mass, something that feels so fundamental, is not fixed. It arises from interaction with the Higgs field, a constant engagement with something that fills all of space. So once again, the same idea returns. Existence is relational. It is defined not by isolated things, but by the network of interactions that connect them. And now, gently, we can return to one of the deepest questions that has been present since the beginning of this journey. If everything is interaction, if everything is a process, then what, if anything, is truly fundamental? Is there a final layer, something that exists independently without needing anything else? Or is the universe itself a self-consistent web, where every part depends on every other, and no single piece can be said to stand alone? Physics does not yet have a final answer to this. Some theories suggest that there may be deeper building blocks, strings, loops, or other entities beyond our current understanding. Others suggest that the concept of a building block may itself be limited, and that reality is better understood as a network of relationships without a single foundation. And perhaps both perspectives are pointing toward the same truth, that the deeper we look, the more reality resists being reduced to simple pieces. Instead, it reveals structure, but also mystery, clarity, but also depth, understanding, but never finality. And there is something quietly comforting in that, because it means that the universe is not something fully closed or finished. It is open, still unfolding, still revealing itself. And we are part of that unfolding. The atoms in your body, the particles that make them up, the fields they arise from, all of it participates in the same process we have been exploring. You are not separate from this structure. You are one of its expressions, a stable pattern within a vast and dynamic system. So when we ask what the universe is made of, we are also asking what we are made of. And the answer, it seems, is not a simple list of components. It is a story of relationships, interactions, patterns that persist and evolve. A story that is still being written. And as we move into the final part, we will allow that story to slow, to soften, to become something you can simply rest within. Because sometimes the deepest understanding is not about reaching an answer, but about feeling the quiet presence of the mystery itself. If you're still here with me, gently drifting through these ideas, let me know by commenting too. Just a small signal in the vast network that you're still listening. As we enter the final part of this journey, everything begins to slow, not because the questions have been fully answered, but because we have reached a place where understanding no longer feels like something to chase, but something to quietly observe. The deeper we have gone, the more reality has revealed itself not as a fixed structure, but as a living process, something continuously unfolding beneath the surface of everything we experience. We began with something simple, the feeling of solidity, the assumption that matter is made of solid pieces. And now, after traveling through atoms, quarks, fields, and forces, that simplicity has softened into something far more subtle. What once felt solid now feels like a pattern. What once felt certain now feels like a balance. And yet, nothing we discovered has made the world less real. In fact, it has made it more intricate, more connected, more quietly astonishing. Because even though particles are not solid objects, they still give rise to stable structures. Even though forces are invisible exchanges, they still create the sensation of touch, of resistance, of presence. Even though mass arises from interaction, it still gives weight to everything we hold, everything we feel. So reality has not disappeared. It has deepened. It has revealed that what we experience is not an illusion in the sense of being false, but an interpretation, a surface-level expression of something far more intricate beneath. And this brings us to a gentle realization. The world we perceive is real, but it is not fundamental. It is the result of layers, of interactions, of patterns that emerge and stabilize over time. And this idea can be both humbling and calming, because it means that certainty is not found in solid foundations, but in consistent relationships. The universe does not need to be made of unchanging pieces to be stable. It only needs the patterns to persist. And they do. The atoms in your body remain arranged in ways that allow you to exist. The forces between particles remain balanced in ways that allow matter to hold together. The laws governing these interactions remain consistent, allowing the universe to unfold in a coherent way. So even within all this subtlety, there is reliability, a quiet order, and this order extends far beyond what we can see. Every moment, particles are interacting, exchanging energy, forming and dissolving patterns. Every second, countless processes unfold within your body and throughout the universe, all guided by the same underlying principles we have explored. And yet, we are only aware of a tiny fraction of it. Most of reality operates silently, beneath perception, not hidden, but simply too subtle, too small, too continuous to be noticed directly. And perhaps this is why the journey into particle physics feels so different from other kinds of exploration. It is not about seeing new things, but about realizing what has always been there. The structure of matter, the interactions of particles, the fields that fill space, none of these are distant or separate. They are present in every object, every surface, every breath. They are present in you. And this brings us to one of the most quietly profound reflections of all. You are not made of stuff in the way it once seemed. You are made of processes, of interactions, of patterns that persist, that evolve, that maintain themselves for a time. The particles in your body are not fixed. They are constantly interacting, exchanging, shifting, and yet the pattern that is you remains stable enough to experience continuity, to think, to feel, to observe. So identity itself becomes part of this deeper structure. Not a static object, but a dynamic pattern. And this does not make existence less meaningful. If anything, it makes it more extraordinary, because it means that what we experience as stability, as presence, as self, emerges from a vast network of interactions that have been unfolding since the earliest moments of the universe. You are part of that unfolding, a quiet expression of it. And as we continue into the final segments, we will allow these ideas to settle, not by adding more complexity, but by gently bringing everything together into a single, calm perspective. Because at the end of this journey, we are not left with a final answer. We are left with something softer, a sense of connection, a sense of continuity, and a quiet awareness that beneath everything we experience, there is a deeper layer, always present, always active, always shaping the reality we inhabit. And perhaps, as we slow down even further, that awareness itself can become something restful, something you can simply drift within. As we continue gently forward, there is no need to rush anymore, because at this depth, understanding no longer comes from adding more pieces, but from letting the pieces we already have settle into a quieter, more unified view. The journey inward has shown us that reality is not built from solid objects, but from patterns, not from isolated things, but from relationships, not from stillness, but from continuous motion that somehow appears stable when observed from afar. And now, instead of asking what comes next, we can begin to feel what all of this means, because there is something deeply calming hidden within these ideas. At first, It may seem unsettling to realize that nothing is truly solid, that everything is in motion, that even the most basic properties of matter arise from interaction. But when you stay with that idea a little longer, it begins to soften into something else, something almost peaceful. Because if everything is interaction, then everything is connected. Not metaphorically, but physically, fundamentally, unavoidably connected. The particles that make up your body are constantly interacting with their surroundings, exchanging energy, responding to fields, participating in the same processes that occur everywhere else in the universe. The same forces that hold atoms together in distant stars are at work within you right now. The same principles that governed the early universe still operate in every moment. There is no separation at the deepest level, only continuity, and this continuity stretches across scales. From the smallest particles to atoms to molecules to living systems to planets to galaxies, all the way to the largest structures in the cosmos. Each level emerges from the one below it, shaped by the same underlying rules, the same quiet interactions. So when you look at the night sky, you are not looking at something entirely separate from yourself. You are looking at the same processes, expressed at a different scale. And this idea, while simple, carries a kind of stillness with it, because it removes the sense of isolation. It suggests that everything belongs to the same unfolding system, that nothing exists outside of it, that even the smallest detail is part of a much larger pattern. And within that pattern, there is no need for anything to be fixed or permanent in order to be meaningful. The universe does not rely on permanence. It relies on balance. Patterns form, persist for a time, and then change. This is true for particles, for stars, for galaxies, and even for us. And yet, the process itself continues, uninterrupted, consistent, quietly reliable. So instead of seeing change as something that disrupts reality, we begin to see it as part of what reality is. A gentle flow, a continuous unfolding. And this perspective allows us to let go of a certain expectation, the expectation that there must be a final, unchanging foundation beneath everything. Perhaps there isn't. Perhaps reality does not rest on something fixed, but on something dynamic, something that sustains itself through interaction. And if that is true, then the search for a final thing may not be the right question. Instead, the deeper understanding may come from recognizing the patterns, the relationships, the ways in which everything participates in everything else. And as this realization settles, something else becomes clear. You are not separate from this process, not observing it from the outside. You are within it, made of it, continuously shaped by it. The same interactions we have been describing, the same exchanges, the same fields, the same underlying principles, they are happening within you right now, quietly, effortlessly, without needing your awareness. Your body maintains its structure not because it is made of unchanging parts, but because the processes that sustain it remain balanced. Your thoughts arise from patterns of activity, your sensations from interactions between particles, your very sense of presence from the stability of these ongoing processes. So existence at every level becomes something active, something alive in the broadest sense, not alive in the biological sense necessarily, but alive in the sense of continuous activity, continuous interaction, continuous unfolding. And there is something deeply restful in recognizing that, because it means that reality is not fragile in the way it might seem. It does not depend on holding everything still. It depends on allowing everything to move in a way that remains coherent. And it does, quietly, constantly, without effort. So as we move toward the final moments of this journey, there is nothing more we need to uncover. No final piece we must find. Instead, we can simply remain here, within this understanding, allowing it to become something you feel rather than something you analyze. A sense that beneath everything, there is motion. A sense that within that motion, there is balance. And within that balance, there is a quiet kind of stability. Not fixed, but enduring. Not solid, but real. As we continue to slow down, letting everything we've explored gently settle, the universe begins to feel less like a problem to solve and more like something to quietly experience. The need to define, to categorize, to reach a final answer begins to soften, replaced by a kind of awareness, an awareness that what we have been exploring is not distant or abstract, but present, here now in every moment. Because everything we have described, the particles, the fields, the interactions, they are not hidden somewhere far away. They are not confined to laboratories or distant stars. They are happening right here, beneath the surface of everything you can see, everything you can touch, everything you can feel. Even now, as you listen, your body is a quiet symphony of these interactions. Particles are exchanging energy. Fields are shaping behavior. Forces are maintaining structure. And yet, none of this requires your attention. It happens effortlessly, continuously, as part of the same unfolding process that governs the entire universe. And this leads to a gentle shift in how we think about presence. We often imagine ourselves as separate observers, looking out at the world, analyzing it, trying to understand it. But at this level, that distinction becomes less clear, because the processes we are observing are the same processes that make observation possible. The same interactions that hold atoms together also allow neurons to function, also allow thoughts to arise, also allow awareness itself. So the boundary between observer and observed begins to blur, not in a confusing way, but in a quiet, unified way. You are not outside the system, looking in. You are part of the system, experiencing itself. And this realization does not need to be overwhelming. Can be very calm, because it means there is no need to separate yourself from the complexity of the universe. No need to stand apart from it in order to understand it. You are already within it, already participating in it, already shaped by the same patterns and interactions we have been exploring. And this can bring a kind of stillness, because when everything is part of the same process, there is nothing that needs to be held onto tightly. No fixed foundation that must be preserved. No rigid structure that defines what is real. Reality is not fragile in that way. It is resilient because it is dynamic, continues not because it remains unchanged. but because it is always changing in ways that remain coherent. And this coherence is what gives rise to everything we experience. The stability of objects, the continuity of time, the sense of identity, all of it emerges from patterns that persist long enough to be recognized. And yet, beneath that persistence, there is always motion, always interaction, always a deeper layer of activity. So instead of thinking of reality as something built, we can begin to feel it as something flowing, a continuous unfolding where patterns form, stabilize, and gently transform. And within that flow, there is no sharp boundary between one thing and another, only gradual transitions, connections, relationships that link everything together. This is true at every scale. At the smallest level, particles are not isolated. They are defined by their interactions. At larger scales, systems emerge from smaller systems, each level connected to the one beneath it. And at the largest scale, the universe itself evolves as a whole, shaped by the same underlying principles. So the idea of separation, while useful for understanding, is not fundamental. It is a way of describing patterns, not a reflection of how things ultimately exist. And as this understanding settles, something else begins to fade. The need for certainty, not because certainty is impossible, but because it becomes less necessary. We no longer need reality to be made of fixed, unchanging pieces in order for it to feel real. We can allow it to be dynamic, to be relational, to be something that exists through its own continuous unfolding. And there is a kind of rest in that, a quiet acceptance that not everything needs to be reduced to a final answer. That understanding can exist alongside mystery. That clarity can coexist with openness. So as we move toward the final moments of this journey, there is nothing left to chase, only something to notice, the quiet presence of everything we have explored, already here, already happening, already part of your experience in ways too subtle to see, but not too subtle to feel. And perhaps as you rest with that awareness, the universe begins to feel a little less like something distant, and a little more like something you are gently drifting within. Now, as everything begins to quiet even further, there is a sense that we are no longer moving forward, but gently settling inward. The questions that once guided us, what is matter, what are particles, what holds reality together, have slowly softened, not because they have disappeared, but because they no longer feel urgent. They have become part of a larger awareness, something you can simply rest within rather than solve. And in that stillness, something subtle becomes clearer. All along, we have been searching for what is most fundamental. The smallest building block, the deepest layer, the final explanation. But what we found instead was not a solid foundation, but a pattern. Not a fixed point, but a relationship. Not a final object, but an ongoing process. And perhaps that is the answer in its quietest form. That reality is not built from something static, but sustained by something continuous. Because at every level we explored, the same truth returned. Particles are not objects. They are events. Forces are not pushes. They are exchanges. Mass is not inherent, it is interaction. And even space itself may not be empty, but filled with structure, possibility, and subtle activity. So when we ask what the universe is made of, we are really asking how it continues. And the answer seems to be through balance, through patterns that maintain themselves not by staying still, but by changing in ways that remain consistent. Like a flame that keeps its shape while the fuel within it constantly shifts. Like a river that appears steady while its water is always flowing. Reality, in this sense, is not a thing. It is something happening. And this idea, rather than being unsettling, can feel deeply calming. Because it means there is no single point of failure, no fragile foundation that everything depends on. The universe does not need to be held together by something rigid. It sustains itself through interaction, through the continuous exchange of energy, through the persistence of patterns. And this persistence is everywhere, in the structure of atoms, in the stability of matter, in the rhythm of stars, in the unfolding of time, and quietly within you, because the same processes we have been describing, the same interactions, the same fields, the same patterns are not separate from your experience. They are the very conditions that make your experience possible. Your body is not a static object. It is a dynamic system, a pattern that maintains itself through constant activity. Particles moving, interacting, exchanging, forming structures that remain stable enough to support awareness, thought, and sensation. And yet, none of this requires effort. It happens naturally, continuously, as part of the same universal process. So instead of seeing yourself as something separate from the universe, you can begin to feel yourself as something within it, not apart from the structure, but an expression of it. And this perspective brings a kind of quiet ease, because it removes the need to stand outside reality in order to understand it. You are already part of it, already participating in it, already shaped by the same principles that govern everything else. There is nothing to reach for, nothing to hold on to, only something to notice, the gentle continuity of everything unfolding together. And as this awareness deepens, even the idea of understanding begins to change. It is no longer about collecting answers. It becomes more like recognizing patterns, feeling connections, allowing the complexity of the universe to exist without needing to reduce it to something simpler. Because simplicity, as we've seen, does not always mean fewer parts. Sometimes it means seeing how everything fits together. And in that sense, the universe is both simple and infinite at the same time. Simple in its underlying principles, in the consistency of its interactions, in the way patterns emerge and persist, and infinite in its expressions, in the number of possible configurations, in the depth of structure that continues to reveal itself as we look closer. So as we approach the final moments, there is no final piece to uncover, only a quiet shift in perspective, from seeing the universe as something made of things, to feeling it as something made of relationships, from thinking of reality as static, to experiencing it as dynamic, from searching for certainty to resting in continuity, And perhaps as everything slows just a little more, you can begin to feel that continuity, not as an idea but as a presence. Something steady even within change. Something calm even within motion. Something that does not need to be defined, because it is already here. Stand now as we arrive at the final moments of this journey. There is nothing left to add, nothing left to uncover, only something to gently let settle. We began with a simple question, something that felt almost obvious at first. What is everything made of? It seemed like the kind of question that would lead to a clear answer, a list of fundamental pieces, a final layer beneath which nothing else exists. But as we moved deeper, that certainty slowly dissolved. Atoms were not solid. Particles were not objects. Forces were not pushes. Mass was not inherent. And with each step, the universe became less like a collection of things and more like a quiet, continuous process. Not empty and not chaotic, but structured in a way that is both precise and endlessly subtle. And perhaps the most surprising part of all this is that nothing we discovered made reality less meaningful. If anything, it made it more delicate, more intricate, more quietly beautiful. Because what we see, what we touch, what we experience is not a simple surface hiding a deeper truth. It is the expression of that truth, a stable pattern emerging from countless interactions, held together not by stillness, but by balance. And this balance is always present. Even now, as you rest, as you listen, as your thoughts drift gently, the same processes we have been exploring continue without interruption. Particles interacting, fields shaping behavior, forces maintaining structure, everything unfolding in a way so consistent, so reliable, that it becomes invisible to us. Not because it is hidden, but because it never stops. And within that constant unfolding, there is something deeply calming, because it means the universe does not need to be held together by effort. It does not depend on something rigid or unchanging. It sustains itself naturally through the quiet continuity of interaction. And you are part of that continuity, not separate from it, not observing it from a distance, but within it, shaped by it, participating in it in every moment. The atoms in your body, the particles within those atoms, the fields they arise from, all of it is part of the same vast structure we have been exploring. The same rules, the same patterns, the same quiet principles. So when you ask what the universe is made of, you are also asking what you are made of. And the answer, as we have seen, is not a single thing. It is a relationship, process, a pattern that exists not because it is fixed, but because it continues. And there is something gently reassuring in that, because it means nothing needs to be permanent to be real. Nothing needs to be perfectly still to be stable. Reality does not depend on unchanging foundations. It depends on coherence, on the quiet persistence of patterns that evolve without losing their form. And as this idea settles, even the need to fully understand it begins to fade. Because understanding at this point is no longer about reaching a final conclusion. It becomes something softer, something closer to awareness, a recognition that beneath everything, there is a deeper layer of connection, always present, always active, always shaping the world in ways that are too subtle to see, but not too subtle to feel. And perhaps that is enough. Perhaps it is enough to know that what feels solid is supported by something deeper, that what feels separate is part of something continuous, that what feels still is gently moving beneath the surface, and that all of it together forms the quiet structure of reality. So now, there is nothing more to follow, no further layers to descend into, only this, a sense of being within something vast, something subtle, something endlessly unfolding. And as your thoughts begin to slow, as the details soften, you can let go of the need to hold on to any of it, because the universe does not require you to understand it in order to be part of it. You already are, and with that, you can simply rest. Let the ideas fade into the background, like distant stars, still present, but no longer demanding attention. Let the sense of structure become a feeling rather than a thought, something quiet, something steady. And as everything becomes softer, slower, calmer, you may begin to notice that beneath all the complexity, there is a kind of stillness, not the stillness of nothing happening, but the stillness of everything happening in perfect, quiet balance. If you're still here, gently drifting at the edge of sleep, leave a soft 3 in the comments. Just a small signal that you made it all the way through this journey. And now, you can rest.